So now with the continuation of perceptron structure, we are going to see about general decision boundaries. So to deal with that input patterns, so in case if it is or not binary, and the neural networks to form that complex decision boundaries. So this may lead to that overfitting, and it may have that less bias. So these classes are classified into that three categories. So and now we have to be see about learning and then generalization. So before that, here we have to see how these red particles that has been classified, and how this light orange particles that has been classified. In case if we are giving that is one test data, the decision boundaries that has to be set right according to the test data. So now, so the learning and generalization, a network produce that is that outputs for the appropriate input patterns with that appropriate marks shown with the question marks, though those classifications also may be incorrect. So there are two important aspects of that network's operation. So one is called the learning and another one is called the generalization. The learning means the network must learn decision boundaries from a set of training patterns, so that these training patterns are classified correctly. And in generalization, after training, the network must also be able to generalize, that is, correctly classify test patterns it has never seen before. So the neural network must learn the decision boundaries. So when set off the training patterns, so that these training patterns should be classified correctly. But in generalization, after the completion of the training, the neural networks must be able to generalize, that's correctly classify the test patterns it has never seen before. So sometimes the training data may contain errors. Example, that is the noise in the experimental determination of that input values or incorrect classifications. So in this case, learning the training data perfectly may make the generalization worse. So the generalization in classification. So the objective of the neural networks is to learn the classification decision boundaries. So to classify that new inputs appropriately, that has to be put into the appropriate boundaries. If that if the training data contains that noise, the system should it necessarily want that training data to be classified with the total accuracy. Otherwise, likely to reduce that generalization ability. So we have to be give appropriate generalization and then classification methods for the same. And generalization in function approximation. So we wish to recover that function for which we only have noisy data samples. So the neural network output give that a better representation of the underlying that function if its output curve does not pass through all the data points. A larger error on that data is likely to lead to the better generalization. And now finally we have to be come to a conclusion of that perceptron. So I hopefully believe you know what is the difference between biological neurons and then so artificial neurons, and what is the perceptrons, and what are all the different types of that perceptron, what is the decision boundaries, and what are all the two important aspects of that neural operation, and what is the classification decision boundary, and what is the general decision boundary. So these are all that important concepts so behind that is that perceptron.